Okay, yeah, you should now see the presentation. So it's kind of an introduction. So we jump completely from the body organ level that we just heard about by Noska to the molecular level, atoms, and so on. And I will have to assume that you know a little bit at least about visualizing atoms and molecules, because I cannot introduce that as well. But roughly it's a bunch of spheres and cylinders, sometimes more complex shapes that you want to visualize. Okay, so my background before I start with Unitymol is originally a computational chemist. And of course, as we work with molecules, I also need to see them, visualize the simulations thereof. And that's how I got into an interest for visualization. And the very first contact was through classical OpenGL programming and so on. And because that was not so, let's say, an amicable encounter, I thought, are there better ways than that to do that? But let me try to do a first test. I think you can all raise your hands in that Zoom application. I would like to know who already has had to do with Unity, which is a game engine that we'll hear more about. So could all those that already know something about Unity raise your hands so I get an idea of how many of you? Okay, super. I got that. That's okay, maybe a fourth or so of people, or a third. Thank you. That gives me an idea. So yeah, Unity is a game engine. It's made originally to develop games, computer games, initially for what's called indie developers, meaning like freelance people who want to do computer games. And of course, that means they have to tap into the graphical power of the computers and try to make it relatively easy to use the graphics cards functionalities for graphics and visualization. And that's basically was the starting point. We thought, okay, maybe that could be a way to develop some scientific visualization application. And when we started with that, like about 12 years ago, the first question was really, can we do a scientific application with such a tool? And indeed, we could. So our interest was in visualizing molecules. So we designed what we call Unitymol, which is a little visualizing software to visualize molecular data. And what was interesting for us, because we're a small lab and we don't have so many people working on that. So with a single software, we could get a full 3D development platform with an access to an advanced graphics engine that's relatively portable and intuitive to use. You can also script it. You can not only do click and drag and drop, but also write in certain languages or link your external code. And in Unity, you work with what's called projects. And from one project, which Unitymol would be a project, you can then generate different instances. You can generate an executable for Windows, or you can generate a web plugin for WebGL, or maybe an application for a tablet. Meaning you don't have to work on the portability of your graphics application. You just really focus on your project, and then everything else, in principle, Unity is taking care of for you. And shameless plug at this point, we're also hiring. We have a postdoc position. So if in any case you're interested more into Unitymol, get back to me. And now let's try and see how it actually looks to work in such an environment. So this is more the classical environment where you have your source code, and then you edit it and you build, compile, and so on. And then you run the executable and you test it. So that's not at all the way a game engine works. In a game engine, all this is integrated. And so let's try whether I can do a live demo of that. So this is a view of the game engine. You can see you have a kind of like an architect's view, where you can see not only the objects that are in the scene, but also some kind of hidden objects that the game engine uses. And below you have the view that the end user would see with a menu, with a molecule visualized. But you see these like shurikens, you don't see them. They are a particle system actually that's emitting some information. And then you have some information on all this scene with parameters being exposed, and you can actually change them while they're running. So this is what I will try demo right now. So I need to stop this screen sharing and share another, oops, where is Zoom now? Share another window, Unity. Now you should start seeing my Unity window. Okay. So this is now the live Unity interface. So you can see here again the view I said, the architect's view and the end user view. This is just a much simpler system. And if I click on play here, oh no, it was playing. So this is now, the application is not running. When I click on play, the application will start running. And despite the fact that the application is running, I can actually drag around things here. So I see at the same time what the end user will see. This is a very minimalistic application. So the end user actually only sees a molecule. He cannot do anything. But I, as a programmer, can just play around with functionalities. It's a little bit like a CAD or design tool. So here you can, display things. You can change, of course, to rotation mode. Then I can turn around the molecule. And this will update in real time. I can change the size, all the things that you usually can do, just to see how it would look. Right, so this is not very, and of course change materials and colors, and all these values that you have here, you can interactively, change something there and see what's happening. I can also, but you don't see it because it's in my menu system. Oh yeah, you see the menu. Create some 3D object, like I can add a cube to the scene. No, I'm not sure where it will add it. Maybe we will not see it. Oh yeah, it did add it. You can see it up here. So you can all do all this interactively. So this is more like drag and drop. Okay, now here's the cube, gets into the view. I can also click on the main camera or the light sources. I can move around the light sources. And you can see how the shading adapts. Okay, I think you get the idea. So this is very useful for interactive debugging, for instance. You can really just try out things here. And as I said, you can also attach scripts to these objects, and then you can programmatically do things. Okay, that's as much as I wanted to show you live. So I go back to the presentation. Just switching this here. Sorry, my computer is getting a bit slow. Now we are back to the tutorial. Let's give you a little background and example of what we were trying to do and how we were trying to explore this game engine. So we had developed some time ago a representation called hyperballs, because it's a combination of hyperboloids and spheres to represent atoms. And so here you have a few typical atomic representations. And this was actually, as I said, very early on done in OpenGL and used shaders on the graphics card. I think shaders start to get a bit low level on the hardware. And the question that we were asking is this directly usable in a game engine? Or do you have restrictions because you start to tap into the hardware? And so that was basically our test case. So this was using ray casting, which is basically shooting a ray on every pixel on the screen, detecting when that ray intersects with your object, here the sphere, and then it decides if a pixel intersects with a sphere, what is the color I should give it on the screen. I mean, that's just to give you the background. I don't go into much details. It's a classical technique in computer graphics. And so we applied it to these molecular objects. And that's what we're basically trying to translate into the game engine to see whether we could have done the same thing we did previously in OpenGL in a game engine, and whether it would be quicker and maybe easier to do. And so here I immediately show you the end results, how it would look like. That should start moving, okay. So this is just a bunch of water molecules that's shown with this representation. And you can see that you have these hyperboloids that form these bonds between the water molecules. So that's done with Unitymol. And so that means the translation did actually work. It was not as easy and straightforward as I mentioned, because of course there are little things in the game engine that are a bit different, but it was still easier than we expected. So basically the shaders, the graphics card code, we could almost copy and paste them from the initial, it was written in a language called CG, into Unitymol, into Unity, that has a way to integrate CG shaders. And the nice thing about Unity also is you can kind of debug even the shaders, meaning that you can see here error messages in the Unity editor about what might be going wrong in your shader. So when something goes wrong, it shows this pink here. That means the object that should have some color or so was not properly recognized. And so then you can try to combine the errors that you have down here with the visual feedback that you have up here to hopefully more quickly debug this thing. I mean, if you don't use something like Unity, this can be actually quite annoying to debug shaders if you don't have a proper tool. So that's why I thought it was nice to mention. You hadn't attached these shaders to game objects. So what we used for every atom, we put a cube, and that cube then got hit by light rays, and that decided which pixel to light and not. The first surprise we had is that the performance was relatively slow. That's actually because of the way that the game engine works on your objects. It's the currency, so to speak, in the game engine is what's called draw calls. And the more draw calls you have, the slower the software will be. And I mean, the naive thing of implementing visualization is like have a draw call for everything, but then you see it gets slow very quickly. So one of the things you need to rethink is how can you kind of put things together in maybe one draw call or so that you can get the number down. So for instance, in the end, instead of creating one cube per atom, we kind of created a mega 3D cubish object for the whole molecule. And it's only one object that you create in one go. Like let's say if you have 1,000 atoms, instead of creating 1,000 cubes, we in one go create 1,000 cube ensemble. And that then gives you a factor of 1,000 of speed up. So this is the kind of things you need to think about. So this is just a more quantitative example. So when we started in the beginning, we got the performance like 100 in an arbitrary scale. And then when we understood this draw call thing and all other things that are specific about the game engine, we relatively easily got up to a factor of 2 of acceleration. And then we noticed other things, for instance, that the graphical user interface, if you want a menu system or so, takes a lot of power as well. And that you can see here when we switch off the graphical user interface, we go from this CPU charge, which is about 40%, down to only 10%. So this was something that was actually corrected by Unity in a later version. But this is the kind of things you learn when you do these experiments. So draw calls I already mentioned, the performance you need to monitor, and you have some tools in Unity to profile them. That will help you understand this. And if you want a user interface that is possibly something that gets your performance down or has other issues. So I see a question whether I use particle systems to improve the performance. Indeed, we have one implementation. So the hyperballs I just showed were implemented in raycasting, but to compare that to a faster thing, we also implemented with a particle system, a billboarding system that was kind of our reference benchmark how fast things could get. So you can also do that, and we used the Unity particle system for that. That was built in for the game engine. So that's the kind of things you can play with. Okay, once you got the thing in there, the nice things you get for free is, for instance, because it's a game engine and people like to have objects look nicely, they have a number of shaders that you can apply to surfaces. One shader was called Matcab that kind of applies a material to any given surface. Basically, it uses an image of a sphere and then uses that texture to map it onto the surface. And that was just pre-existing, and we just connected that, so to speak, to our molecular viewer, and then we got these nice shapes, well, these nice texturing just for free, just using the already existing feature in the game engine and connecting it to our molecular visualization stuff. So this is the nice type of benefit that you can get from using such a tool. And of course, we had some fun with this. This is all using the same texturing on a simple molecule. I think it's caffeine. and just with using different spheres. And this is all just done on the frame buffer level, so it doesn't have any performance cost. So it's very easy and quick to do this kind of let's say aesthetic triggering tweaking. Okay, now how do you do things in Unity? I mean, doing like molecular visualization. I have 2-3 examples. So this is again this kind of editor view. It's a little more sophisticated. Here you can see a molecule combining different representations that you have shown, a heme group here, and then there's a little protein part wrapping around that. This is the kind of architect's view in Unitymol, and these are the different things that are exposed. And then you can kind of select things here, and you can see that there's some effect there. And then you can change some values, for instance, the color. For instance, here we'll change the color of the ribbon here, just going through this user interface with all the features of the objects that are exposed natively by Unitymol. Meaning, without you having to implement any way to change the color, you can just use the feature of the Unitymol Unity editor where the colors are already exposed and change them. You don't need to program this feature. A second example, because from time to time I teach like stereochemistry. Stereochemistry is, let's say, the orientation of things, in particular in sugars, and where you learn that some object and mirror copy of the object can have different properties. So this is such a short segment of a sugar, and now I wanted simply to add a mirror in that scene to show my students what the molecule and its mirror looks like, and then you just add a plane in Unity, and then you give it a texture that reflects light, and then you have your mirror in the scene, and then you can move it around, and you can discuss about the molecule and its mirror image very, very easily. So that's a kind of a 1-minute extension of the software that's very, very easy to do. Of course, some of the things that you change here, you don't want to go every time through this user interface and change it manually. You want to be able to do it repetitively and let's say programmatically, so that you have a reproducible result. And that's actually why we combined in Unitymol a Python interface. So in Unity, you have something that's called IronPython that you can call. And then you can actually expose any of the functions that you program to this IronPython interface. And so here you have an example of that. Unfortunately, it's very small. I'm not sure you see much, and also because the slider of the video, it actually just hides the text. So I'll just go back there again and then not go on the video so that you can possibly read what's going on there. So here you have a very small protein. Okay, is it playing? Oh yeah, no, it's playing. Oh, I can't get rid of the GUI actually. So then you switch on here these hyperbole representations. You will switch on in the Python interface some hydrogen bond animation, and then I think it switches off the hyperboles again and changes some orientation of the thing, and then switches this on again. And you can see this here actually moves up, and it will give a history, and that's actually also in memory. You can store it to a file, and then you can just reload the file and replay it if you want to reproduce a visualization that you liked in Unitymol. And that you can actually program this. You can put loops into that, and then say, I don't know, change the color of a molecule every 10 seconds or whatever. So that's actually very helpful if you want to automate things. So I'm just checking whether I see any other questions or hands raised. No. Now, one thing I wanted to talk about as an example, and I think it also gives a nice overview of what you can do with something like a game engine, is sharing the visualizations. If you do some work in molecular visualization or other visualization in Unity, and you want to share it to other people. So we try to work on that in the context of really share it so that it can be easily found, and then you can put it in a database and people can find it, reference it. And we did that on the background of COVID-19 data, typically molecular systems that are related to the virus or to drugs against it and so on. And the idea was, how could you share for somebody who does not have the skills to do the visualization himself, the visualization end products that people have prepared, for instance, that go with a paper that explains some new drug or some new way of interacting, of inhibiting the virus or so. So our suggestion was to go through some visualization software that you could script so that you have a reproducible view. Eventually you could extend it with some customized content, for instance, some menu that helps the end user to get quickly to the view that he wants to see. I think I have just an example of that for you. So here you have such a view down there. This is a spike protein of the COVID-19 virus, and that's a custom menu. I zoom in on that, and where we have just exposed like the functionality that we thought that the end user would like to see. Maybe I toggle some annotations on and off, hop to specific viewpoints. I mean, whatever you choose is important. You can just add it in a very simple interface that can be scripted. This, I think, is TCL/TK, meaning it's very, very simple to script. You don't need to go actually into Unity if you want to do that. And so you can kind of shortcut the Unitymol graphical user interface. If you think it's too complicated, you just need 4 or 5 functionalities. You can easily hook up your own interface to make it simple to use. Okay, so this was just one example. And so what something like a game engine allows you to do, for instance, of course, you can take snapshots of what you see and then you get images that you can share. Also, obviously, you can generate movies and animations. That's all very classical. But you can go a step further. You can very easily also just create a 3D model of what you're visualizing. That's useful for people who are skilled in 3D modeling but do not know anything about molecules. You know, they might use 3ds Max or I don't know, Maya or whatever, and they just want to do something, maybe let's say again about the COVID-19 virus. You could just prepare your visualization in Unitymol, and then you export a 3D virtual model, let's say GLTF, OVG, or FBX, and then they could use that without knowing anything about molecules. Or you could want to go even more involved, 3D visual experiences, maybe with a 3D headset or 3D glasses or so. You could also explore that and export that from Unity, and then use it either as an offline standalone, or maybe for Google Glasses, or with a cloud visualizer. So you can also go a little bit beyond standard things. I mentioned movies. So one thing you see not so often is 360 degrees movies. That's one tutorial example I will give more details about. So first I will show you what this is about. So I switch again to another screen. So let me stop this screen sharing and share another one. Zoom, where are you? Now you should start to see in a second, yeah, a movie playing. So this should just look like a standard movie, right? But it's actually a 360 degrees movie. So I just paused it, and now I can actually rotate the scene and look at things different from my initial viewpoint. And I can actually do that and continue playing the movie and still move around and see not what the person who prepared the movie wanted me to see, but whatever I like to see. So I think the internet connection is a bit slow, so not much may be happening, but the movie is actually playing. It looks like it's stuck. So I play it again. Oops. Yeah, maybe having Zoom and Unity and is a bit much for my computer. So now I just play the movie through. So this type of 360-degree movies, you can actually upload them on YouTube, and they can give you an interface so that people can use it. So for some reason, it does not update. I can see that, and I don't know why, but it does work. I mean, you can see that I move around. You just can see that I make it working. And this is something you can prepare also from Unity. Now, it's not something you can just out of the box do with a standalone application. For this type of thing, you need to go in the Unity editor, and I will show you in a second how you do that. I need to go back to Keynote.
Marc, you are muted.
Yes, I was. Sorry, must have gotten onto some button. Okay, so I just go back a little. So I was saying, I was explaining how to generate a 360-degree movie in Unity. So there's a tool that's called a recorder that you have from the editor. So that was just opened here. Then you add a new recorder of a movie. And then you choose or whatever name you want for your project, for the movie. And then you choose where the file is about to go. And which view you can see here, it was chosen 360 view. And that will mean that it will use a camera with a 360-degree view to record your movie. And that's all you have to do actually to do that. So then we just start where we choose the resolution, whether it's stereo or not, whether capture audio, and then we can start recording. And from now on, anything we do in, well, here Unitymol or whatever Unity projects you have open will record as a 360-degree movie. So here we'll just open, you can see we type in a PDB idea, load a PDB from the internet, some default representation that shows up, then add some, hide some things. And then we start moving this around, and this will just record everything as a movie. It would be a movie showing around through the molecule. And then you click stop recording, and that will deposit the 360-degree movie on your hard drive. And that then you can export, for instance, to YouTube and share with other people. So there are a few extensions like that in the Unity editor that you can have. How about the frame rates by using this recording tool? Well, I think it must depend on the hardware. We were doing it on a computer that we usually use for VR, so it has a relatively powerful graphics card. It was a 2080 RTX, and that was, I don't know, I would say between 20 and 30 frames per second. So it was not an issue. I mean, this 360-degree camera does not seem to have a large performance overhead from what I saw. We haven't quantitatively analyzed it, but I don't expect any big issue there. And this is just another movie, a little bit more sophisticated with some scripting going on that decides which amino acids are to be highlighted. And again, I think my connection is too slow to have this movie playing smoothly. While you could find it on the internet, I think it's on YouTube or on the supplementary material to that paper. But I think you get the idea, just to say that you can then combine this kind of 360-degree and the reproducibility and the scripting to facilitate your job. Okay, so at some point, I mean, this was relatively, I would say, basic stuff that, I mean, I haven't really gone into Unity itself because there are many, many very good tutorials out there that you can find. And, in a few days, you get the basic idea of how to get around with Unity. And the molecular stuff I just talked, I mean, Unitymol is available, can be downloaded. Also the project code, you can play with it, or there are other codes around. So that's relatively easy to get, let's say, started with something. Then the thing is, if you want to kind of get more control of what you're doing, then you need to learn more about how the game engine actually works, how it does the visualization, and what the issues may be. So I will give you one example so that you may see better what I mean by that. One of the things we were doing was, what you heard briefly about CryoEM in the previous talk, was to create some surfaces to work on CryoEM data, and in particular a data set where this is animated, where you can have structures that are slightly changing conformation that you can see here, maybe, if my internet connection is not too slow. So that was just, let's say, hacked quickly together in a few months. No issue here. The issue we had was with the surfaces. So as you can see, the surface is quite rough and it has some issues with normals. And that actually took us some time to work out in Unity why that was happening. So there was some issues. You can see here first pass where we moved from the left image that was very rough to right image with a more smoother surface, where we had to add some path with some additional sampling for the smoothing of the surface. And then there were other issues when you try to put shaders on the surface and so on. I won't go here. You can see the issues that we have with the shaders, for instance, down here. So just to tell you that there are, once you start to look into more the details, then you will find things that maybe you don't understand, and to really work them completely out, you will need to understand how the game engine internally works. And that may take some time. So that's to say, yeah, doing some quick and rough prototyping is very, very easy. But then to get really very results that you have complete control over, that takes some time. And at some point, the issue that we had with the surfaces was also the performance. And then we actually completely changed. Instead of the first surface I showed you were completely done within Unity using, for instance, C# scripts. That was okay, but very slow. And then when we wanted to have more interactive experiences, then we had to code it on the GPU directly. And in the end, we actually did that with with a code external to Unity. And we just linked that code to the Unity engine, which you can do very easily. That's actually a project you can find also on GitHub and on the internet called QuickSess. And then you can get, this is roughly for this small molecule, the time with which you could calculate the surface. So not completely fluid, but still relatively okay-ish to look, for instance, at the trajectory of small molecules. So depending what you want to achieve, you may need to put more or less work into getting the game engine to do what you want. So as I said, in this strategy, we used an external library. We first tried existing ones, and then in the end, we wanted to implement something into CUDA to have more control and get better performance, which is this QuickSess. And the last evolution with the surfaces, actually Unity has now in the very latest versions some path tracer implemented that can work, for instance, on GPUs. There were also some codes like OSPray that works on CPUs, and we then hooked those up to the geometries we already generated and got these kind of interactive ray traced images also with this process. So there's many things you can play around with by connecting things that other people do and then leverage the things that you've done in your unit project. Okay, and the last thing I wanted to mention that for us was very interesting is that with something, a game engine like Unity, you get a number of things for free. One is, for instance, access to technology, because of course, usually games want to try the latest technology, at least technology that you can use for games. Typically, you will find an SDK for all the things like VR, AR, and so on that are currently trending. So this is just an example here with Vuforia, where we kind of connected our molecule to a real world object. Here, this sheet of paper with some motif printed on it. And then when you move the sheet of paper, the molecule attached to it moves. So this is the kind of thing we try to imagine to use for teaching, for instance, to make the 3D molecules more fun for the students. Before I give you more examples on this, I wanted to make a brief summary of a few advantages and disadvantages of using a game engine for doing these visualizations. So the development cycle is quite shortened because you have this interactive way of working with the software and tweaking it while it's running. You have this quite extended hardware support, be it for graphics cards, be it for, like I just showed, VR, AR gear and frameworks. You have, at least for the initial things, you will do a relatively low learning curve. There, as I mentioned, are very good tutorials, videos, and so on that get you started very quickly. And it's relatively cost and time efficient. And it's rather flexible. As I already mentioned, it's very tough if you want to get high performance out of it. The game engine, of course, they have some development milestones that they follow, and they might not always be in line with what you expect or hope. Like if they drop, for instance, the support for your favorite toolkit, that might be bad for you, so that you just have to live with it. That's the way it works. And it also depends a little bit on the popularity. I think we were lucky when we started with Unity because it was relatively new when we started, but then it got used quite a lot. And so now you can find a lot of people answering tutorials and forums and so on. But maybe some other game engine, if it's less widely used, you may have more difficulties if you run into an issue to work out a solution. There's always a little bit of digging involved. Okay, and then just to extend on that theme of the things you get for free. So we in particular are interested in VR a lot. And so the access to the different VR gears, you get SDKs for all the current ones. So here you can see Oculus Rift and Leap Motion, for instance, Vive, HoloLens. That's all very easy to experiment with Unity. Here more examples with a HoloLens where we try to get, again, more performance that they needed some tweaking, for instance, of the surfaces, where I needed to simplify the results from the original one that had like 2 or almost 3 million vertices to less than 500,000 to get it more fluid. This is the kind of things you need to work on. Or here we have a display wall in the institute. We also got it to work on that in stereo. Or we wanted to explore like web VR. We could find some experimental web VR standard plugin for Unity. And so that's all things that you can explore without getting your head too scratchy about the technicalities. Okay, and then I have a few more examples, but I think maybe now I could more take the time to take some questions, and I can see there is at least one in the question and answers. Are there many ray tracing based projects for rendering proteins and molecules, especially in interactive rendering? Well, it depends on what you call many. There are a few usual suspects. Maybe some of you know the VMD, molecular visualization software. They have for a long time a ray tracer that was bundled with it, initially to do movies or to do images. And they also have some extensions so that you can do some interactive ray tracing. So that's one of the projects I know about. I think I saw one, but that's no longer active. I don't actually recall a name, by a guy in Switzerland. I think he's now working on the human brain project and used a ray tracer to do some ray tracing on brain images or brain models. But I don't think he's doing molecules anymore. But I mean, there are several kind of, like Unity has now ray tracing extensions that you can tap into. And there are a few ray tracers like OSPray that I already mentioned that are around. So I think there may be a few projects that are around, maybe a handful, I would say, 3, 4, 5, 6, probably not more. But you can do quite reasonable things now interactively. If that answers your question, I don't know if there are any more questions. You can just still move on to the next slide. This was just an example of combining the virtuality with also manipulating the scene. So this time the visualization is not fixed, but you move around the molecules and you have some visualization that updates, for instance, here of the interactions. I can see it's very slow, so you don't get a very good representation, but I hope you can still get the idea. Any more questions? I can see, was it possible to enable fluid interactions with the HoloLens despite the huge amount of data? Yes, I mean, let's say we simplified the view until it got fluid enough so that we could do some experiments. It was actually an experiment where we had 2 HoloLenses and people were looking, well, the 2 participants were looking at the same object that they shared, and they could point to it and one could like turn it around and try to explain things. And it was fluid in like you could move it around. It did not move super fast, but fast enough that you were not annoyed to do it, at least not for 5 or 10 minutes. And we basically stopped there because it was an internship project and then the internship ran out. So maybe there would have been more potential to move further on that. It was actually a complicated molecule. It was a ribosome we visualized. So the ribosome we got in, I don't have the numbers in mind, but I don't know, 12 or 15 frames per second. A ribosome is like 250,000 atoms or so. So I think if you chose a smaller molecule, 10,000-ish or so, you could move it very reasonably fast and fluidly around. Any more questions? Okay, while I answer the next question, I just also do not want to forget to put up the credits, and in particular, the one of Xavier Martinez, who implemented many of the things I showed and has worked a lot on the most recent Unitymol version. So I can see I'm interested in sharing with collaborative users. Can you explain how the data synchronization work? Yes, so we use a third-party framework to basically send the commands. I mentioned we have the scripting language in Python, right? So whenever you do something, it generates a Python command that is typically also written to a script if you want to save your current state. And when we have a collaborative session, it means the commands a user executes, they are sent to all other clients that are connected. And actually every client is both a client and a server. So everybody can execute a command and anybody sees what is done in interactive time. So it is still in beta, so I don't have something that I can show you, but it is working and it's relatively straightforward. So
since you are taking questions, there is also Stefan Zachov is asking whether did you also try to visualize large voxel data sets?
Good questions. What about what we did some tests Some fields, some calculated fields we used, but I would not qualify them as large. I don't know, they were they 256 cube? Maximum 256 cube, I think. It was not, I mean, it basically depends on the configuration of your machine. I mean, if your machine has the memory, the graphics card that goes with it, Unity can use that quite effectively, but you need to put the hardware into your machine if you wanna use those things. There is an overhead by Unity, that's clear, so you always get, I would say, minimum 10 to 15% performance overhead compared if you would do something like in an optimized OpenGL tool or so. But yeah, so I hope it can answer the question. So the other question I see in Discord is from the videos. I wonder whether there's a huge delay for Unity in interacting with large data sets, hundreds of cells. I don't know. I mean, at some point, we stopped with the level of performance optimization we try to get out of Unity. Because, I mean, the pace with which the graphics cards and the computers get faster, you know, like the 2 to 3 months it takes us to improve the performance, probably the graphics cards will have done the same performance improvement. So we did not, you know, at some point there was the pain barrier that we did not want to cross. What I'm trying to say by that is, if you're really a geek and you want to get the most of performance of Unity, I think there is still some, you know, buffer that you can tap into that we did not try to explore. So if you take Unitymol, the current Unitymol, there was no particular focus on the performance, except that because we do a lot of virtual reality, we still work, for instance, a lot on the shaders so that they get fluid enough so that you don't get any bad like motion sickness or so in VR with systems of reasonable size. I don't know, tens or hundreds of thousands of atoms should be fine. If you want to see 1 million atoms, don't do it in VR, you will get sick. Yeah, that's roughly where we are with Unitymol. Okay, I see a comment about IronPython. I actually don't remember which version we have currently implemented. So yeah, it's the 2 to 3 Python transition is still a bit painful from time to time, but I mean, it will flatten out in the end. Yeah, just see. I think I'm through what I wanted to show you. So, I mean, if there are no more questions, you can anyway drop me a mail or drop another question on Discord. I can still answer later on. And as I mentioned, we're hiring. So if you know somebody or if yourself interested, don't hesitate to get back to me. And well, I hand back to Jan.